This assignment is to program in the Eclipse to turn on the LED R0 and shift left until LED R17 is on. When LED R17 is on, then shift right until LED R0. And just go back and forth. So essentially just shifting left and right, shifting the LEDs left and right. And there can only be one LED on at all times. So there cannot be any overlapping. That means we need to grab the value of the highest bit value, so the MSB value for each point of the LEDs. The other thing that we need to do is also use the interval timer to shift the LEDs every 1 second. For every second. And then we can also change the speed of the LEDs by pressing key 1 through key 3. And key 0 is for starting and stopping. However, since I mentioned previously, key 0 cannot be used as an interrupt because it is a reset on the top module. Therefore, we will use switch 0 interrupt as a start and stop. So first I'll show the code portion. So we have very similar to kind of just building off of part 1 and part 2, since we are using the timer once more and we are having a 1 second clock. We'll just leave that as is. For our timer ISR, however, it will be slightly different. This is the part that will display the LEDs because it is going through the timer and then running the timer ISR, and it does have a higher IRQ, so you'd want it to run in here and display here as well. So very similar to part 2, except now we are having something else counting. So our count is essentially our value that's going to display, and our index is just the position or location of each bit. So this is where we do 2, and we're using the math function pow. So we do 2 to the power of the index. So for example, our index is 0, then it's going to be 2 to the power of 0, which will light up LEDR 0. If it's 2 to the power of, so it's going to increment the index, right? So once you get to the next index, it's going to be 2 to the power of 1, which will be 2. It's going to light up LEDR 1. And then 2 to the power of 2 is going to be 4. It's going to light up the LEDR 2. And it's going to keep going. And then similar to the last one, it's going to check if the index has reached 17 or 18. Technically, we're doing 18 bits here, but it only goes up to 17 because we use 0 as one. Is included as a bit. Therefore, it's 0 through 17. So it's like the last one, we're going to change the toggle. So once the toggle gets changed, it's going to go back and do the timer interrupt. Once it gets interrupted, it goes into the timer ISR, checks what the toggle is. If the toggle is high, then it's going to increment. If the toggle is low, it's going to decrement. Then it's going to check the index, make sure that the index and toggle is decrementing and incrementing accordingly. After this is all executed, it will display on the LED, and then it will continue running the timer as usual. The next part is the keys. So we'll have the initialize the interrupts for all the buttons. So I wrote them all together. Actually, I did not write them separately. I got help from friends that did write their interrupts in separate sections. I found that I was having a lot of issues, and I think it's because I am using the falling edge instead of falling level in the QSYS, which is okay. I mean, I think the coding might be slightly different just because of that, and I think they used the falling level for theirs too, but I'm not too sure. So same setup as the last one. We have the recast the edge capture pointer so it can match all IRQ, and then we can enable all the button interrupts. Then you reset the edge capture register for the the PIO, so that's for the key base, so for all the keys. And then you register the interrupt handler, and this goes into the handle button interrupts. And then the switches, it's a little slightly different. So we're not going to do all this because I'm only checking for one switch. So I am going to write into the, I'm going to mask the IRQ for switch 0. So that will be written here. And that's just checking, this is just for switch 0. And then also writing the, clearing the edge capture for switch 0 as well. Then we are writing, let's see, to the Alt IC ISR register, also going to the handle button interrupts as an ISR, or to then it will go into the ISR after it goes to handled the button interrupts. So if either of these run, then it goes to this handle button interrupts. So it's going to check the edge capture. If it's a certain key, then it's going to run into the corresponding ISR. So if it's key 3, if the edge capture is at key 3, it's going to point it to, or take it to the key 3 ISR, so on and so forth. And then we will recast the edge capture to check the switches now, because we had it originally at the key, and then we're going to check the switches as well. We just have it all in one function. It just makes it a lot easier. You don't have to write too many functions. Then if the edge capture pointer is 1 for switches, then it will, because I already activated, I masked the IRQ as 1 for the 0, or for the switch 0. Sorry, 1 for switch 0, because that's when it's high. Then it will go into the switch ISR, and then I reset both of your edge captures for keys and your switches. We added a debounce just because it's checking keys and switches, so we don't want any overlapping. I will change this to 5 seconds though, just so it can be a little faster. Don't want too long of a debounce. So here's the corresponding. The key 3 will shift the LEDs every 1 second. So this is, I'm literally grabbing the timer, initializing the timer, like from the period here. Grab all of this. It has the setting the bit high so you can stop the timer, change the value, then load all the periods, then turn on the timer again. So have this. Don't include the Alt IC ISR register because you're not initializing a register for the timer. You're just using this function here. You can also write a more general one and use this as well. I didn't do that. There's really there's a lot of things, a lot of ways to write this, so this is the way I wrote it. And so I did the same thing. I also displayed the key interrupts on the board, and which keys interrupting and what is it shifting at. It's shifting at 1 second. So this is, you multiply by 1000 for 1000 millisecond, which is equal to 1 second. Load the period. After that, you're going to reset the edge capture. For key 2 ISR, it's shifting at 250 milliseconds. So instead of, since it's a millisecond now, it's the exact millisecond value that you multiply to the system timer load value, which is the period. After that, it's the same setup, so the only thing that's different is this and this. And then we have one more for key 1 ISR. It's at 100. Oh, this is wrong. This is 100. It should be 125 milliseconds. And then if we are resetting, we have the switch ISR. So we'll do the switch interrupt. It's checking the system timer. If it's 2, then we stop the timer. If it's not, then it starts the timer. So setting the high bit, just 8, and then setting 7 to start. 8 to stop, 7 to start. Then make sure you reset the edge capture, and this is the same function from the last assignment. And then these are all the other functions that were created. So now we'll show the demonstration on the board. So I already built it, so we'll just run as Nios II hardware. And here it is, shifting left. So it's shifting left by 1 second. So key 3 should just keep it as 1 second. It didn't do anything, so press key 2. So now it's going faster. This should be 200, or sorry, 500. Sorry, no, 250 millisecond. This is 125 millisecond. If I flip the switch, it should stop. So it stops. Switch 0 will start it as well. So notice how it doesn't stop. This only stops at the edge, so you need to essentially flip it back down, and then same thing, flip back down. So this is how that works.